Welcome to the Deep Dive, where we take your stack of information and turn it into the crucial, fascinating insight you need.
And today is a big one.
It really is. We are putting reality itself on the operating table. We are diving headfirst into the simulation theory.
The idea that everything you know, every memory, every single sensation, is all just running on a massive computer somewhere.
And this isn't just, a fringe sci-fi concept anymore.
Not at all. It's gained serious traction. We're talking about people like Elon Musk, Neil deGrasse Tyson, and the Oxford philosopher Nick Bostrom.
All of whom have said, pretty publicly, that this isn't just possible.
But that it's statistically probable. It's the ultimate existential shortcut.
So, to get your head around the core concept, think about a video game, but like a hyper-realistic one.
Right, not just any game. Think The Sims or Grand Theft Auto, but on a scale that's, well, almost impossible for us to imagine.
Those characters in the game, they operate under a set of rules, right? A kind of physics.
And they have thoughts, they have memories, they even feel pain, all based on their in-game childhood.
But to us, the player, they're just code.
Just data. And that leads to the big question, the one we're really tackling in this dive.
Which is, how do you know?
How do you know that your entire life, all your memories, weren't just programmed into your consciousness, say, 5 seconds ago, when the player loaded up the game?
That is the thought that will keep you up at night. Okay, let's unpack this. And the place to start, maybe the most compelling argument, it's not even physics, it's just cold, hard statistics.
Exactly. It starts with the philosophical foundation laid out by Nick Bostrom back in 2003.
His paper introduced something called the trilemma.
Right, the trilemma.
Yeah.
It's a logical argument, and it's very powerful. It basically states that when you think about the future of a technological civilization, one of only 3 statements has to be true.
Okay, so let's walk through them. The first 2 options kind of require humanity to fail, right?
The first one is the extinction event.
Which is pretty much what it sounds like.
It suggests that any advanced civilization, like ours, just inevitably destroys itself before it can ever develop the computing power needed to run these kinds of simulations.
We blow ourselves up before we become digital gods.
Basically, yes. Then there's statement number 2, which is a little different. It's the boredom theory.
So in this one, we do get the super technology.
We do. We reach that supreme technological power, but for whatever reason, we're just not interested in running digital history lessons. Maybe we become ascetics, or our values just shift completely.
I have to push back on that one a little. I mean, if a civilization has, like, infinite computing power, why wouldn't they run simulations?
Curiosity, right?
It's just a fundamental driver. It feels really improbable that they just stop being curious about their own past.
And that's exactly why most people who follow this theory tend to dismiss number 2, which brings us to the third statement.
The big one. The simulation outcome.
That we are almost certainly living in a simulation. And the statistical argument for this is so simple, it's almost devastating.
It really hits you. So, assume we survive, say another 1,000 years, our computing power will be
exponentially greater, unimaginably powerful.
So we'll definitely have the ability to run simulations of us, our 21st century ancestors.
Absolutely. And if that advanced civilization runs one simulation of history, they're going to run millions of them.
Or billions, to study everything, right?
Mm-hmm.
Social patterns, economics, politics.
Exactly. And when you factor that in, you realize there's only one real reality. Just one.
But there are millions or more of these fake simulated realities all running at the same time.
The numbers just become overwhelming. If you are a conscious being, your consciousness is millions of times more likely to exist in one of those simulated realities
than in the single original base reality.
Yeah.
It's just a matter of probability.
There's an economic argument there, too. I mean, the cost of generating conscious experience in code is tiny compared to building an actual physical universe.
It's just more efficient. So the math points to us living in code.
Yeah.
But that brings up the question that I'm sure you're thinking right now.
Why simulate me?
Exactly. Why simulate me sitting in traffic? Why are all the boring parts here?
Well, it comes down to stability and realism. A good simulation needs consistent background detail.
So without the traffic, the waiting in line, all that mundane stuff.
Well, the simulation would feel fake, or it would just become unstable. It needs the boring details to hold together.
And this is the really humbling thought.
Oh, yeah.
Maybe you're not the main character. Maybe you're just the background traffic, a really complex NPC.
A non-player character, yeah. You're just there to enrich the experience of the actual player who lives down the street. That's the resource optimization part of it.
Okay, but this is where it gets really interesting for me. Because if we are in a program, physicists say we should be able to find, like, actual clues.
Hard physical evidence in the code of the universe itself.
And a lot of the weirdest rules of physics, they line up surprisingly well with the limitations of a computer system.
Let's start with the resolution of the universe. For centuries, we just assumed reality was smooth, continuous.
But quantum mechanics kind of blew that up.
It did. It tells us there's a smallest possible unit of measurement, the Planck length. It's about 1.6 times 10 to the minus 35 meters. It's unimaginably small.
So reality isn't a smooth painting, it's more like a digital image. It's blocky.
It's quantized. You can't have half a Planck length.
And the computer parallel is. I mean, it's instant. It's the pixelation of the universe.
Exactly. You can't have half a pixel on a screen.
Yeah.
The simulation has a built-in resolution limit. It's a way to manage resources.
That makes perfect sense from an engineering perspective.
Yeah.
But hold on, couldn't the Planck length be the way physics is?
That's a fair counterpoint.
Isn't it possible we're just imposing our own technological ideas onto the universe because that's what we understand?
It's absolutely possible. That's the critique. However, when you look at the next big constraint, the cosmic speed limit, the computer analogy gets even stronger.
The speed of light.
Why is there a speed limit? Why can't anything, no matter how much energy you pump into it, go faster than the speed of light?
If we're applying the software analogy, then maybe it's the processor speed.
Precisely. The rendering speed. Think about a video game. If an object moves too fast, the computer can't load the new environment in time.
The game lags. It freezes or crashes.
The speed of light is that stabilizing limit. It's the maximum processing speed the system can handle to keep reality stable and coherent.
So it's not a limit of space-time, it's a limit of the computer running space-time.
And then you have the weirdest one of all, quantum entanglement.
Einstein's spooky action at a distance.
Yeah. You link two particles, you separate them by light years, you change the spin of one.
And the other one instantly changes its spin at the exact same moment, faster than light.
Which should be impossible in our physical reality.
But it happens. But from a simulation perspective, the distance on the screen is huge, but in the code.
In the code, they're right next to each other. The distance in the simulation is totally irrelevant to the system's logic. It's just a shared variable.
A line of code that just says particle A dot state, particle B state.
That's it. It ignores the physical boundaries because the command isn't traveling through space. It's just being processed by the system.
Okay, so if the universe is software, then we shouldn't just find these rules in the physics. We should also find, bugs, glitches in the system.
And that's where we get into these fascinating psychological anomalies. The glitches in the matrix.
The most famous one has to be the Mandela effect.
Oh, for sure. It's this phenomenon where millions of totally unrelated people share the exact same, very specific false memory.
And the examples are everywhere, like the Monopoly man.
Ask anyone. They'll tell you he wears a monocle.
He's never had one. Not in any version.
Or in Snow White, everyone remembers the evil queen saying, "Mirror, mirror on the wall."
The actual line is magic mirror on the wall.
And the one that gets me every time is the Darth Vader line.
Luke, I am your father. It's one of the most famous lines in movie history.
Except it's wrong. The real line is, "No, I am your father."
The fact that so many people have the same incorrect memory is staggering.
And the simulation theory offers this wild explanation. What if the developers released a patch, an update to reality?
They corrected a small error in the timeline, maybe a line of dialogue.
But they forgot to delete the old cache files, the ones stored in our long-term memory.
So we're remembering version 1.0 of the simulation.
It's a thought experiment.
Yeah.
But hang on, I can see your point. Isn't this far more likely to just be, a quirk of human memory?
Well, that's the rational explanation, right? We know memory is unreliable. It's susceptible to suggestion. So to jump straight to a patch, miss the cache files, feels like a huge leap.
It is a leap, absolutely. And that's the critical thinking you need. But the simulation model, it provides a mechanism. If it's just psychology, why is the false memory so specific and widespread? If it's a stimulation, the mechanism is simple, corrupted data. The model just works beautifully.
That's fair. And it connects to other things too, like déjà vu.
Right, that sudden, intense feeling you've lived a moment before.
That's just a server-like spike.
The simulation processed the moment twice. A quick, jarring reload.
And then there's the one that feels a little unsettling. The NPC phenomenon.
You're in a crowd, a busy airport, and you look around at the strangers.
And they just seem to be running these simple, repetitive scripts. Walking, stopping at the light, looking at their phone. They don't feel all there.
It taps right into this old philosophical idea of solipsism.
The idea that only your own mind is certain to exist.
And in a simulation, that has a terrifying implication. If this is a single-player game, then you are the only real player.
And the rest of us. The hosts of this deep dive.
We're just sophisticated chatbots. Programs designed to make your experience feel real.
That's the ultimate resource optimization. Why render the inner life of billions if only one person's paying attention?
Exactly.
So moving from these clues to the biggest context of all, why? Why build us? This gets into the design specs of reality, and maybe the strongest evidence for a programmer is the fine-tuning argument.
People call this the Goldilocks universe.
Because everything is just right.
Perfectly impossibly tuned for life to emerge. The chances of it happening randomly are so small, it's basically zero. It's far more likely someone set the dials.
Give me a couple of the best examples, beyond just gravity being the right strength.
Okay. A great one is the strong nuclear force. It's what binds atoms together. If that force were just 2% weaker,
Only 2%.
just 2% weaker, and only hydrogen would exist, nothing more complex could ever form. If it were 2% stronger, hydrogen wouldn't exist, and you'd just have a universe of heavy, useless elements. No stars, no water, no life.
That is an incredibly fine line.
Another is the mass ratio between an electron and a proton. If that ratio were even slightly different, the chemical bonds needed to form molecules would be impossible. Life couldn't exist. The precision is just staggering.
It's like finding a radio in an empty room that's already perfectly tuned to 105.7 FM.
You assume someone turned the dial.
And the theory suggests the creators ran billions of failed simulations. Crashes where the variables were wrong. And we're just in one of the successful beta tests.
But if you accept that, if you accept that there was an intentional design.
You run straight into the ethical nightmare. They also programmed suffering.
Exactly. Why program cancer? Or war? Or earthquakes?
Well, option one is the simplest. They're cruel. This is just sadistic entertainment for them.
A darker but maybe more utilitarian option is that conflict is necessary for the data. You learn nothing from a simulation where everyone is happy all the time.
They need the pain to get meaningful results.
It's cold, but it makes a certain kind of sense. Or there's option C. They're not in control anymore. They just hit play on the Big Bang and they're just watching to see what happens.
But no matter what their motive is, the ultimate threat is still there.
The delete key.
The entity running our simulation gets bored or needs the hard drive space back.
And the end of the world isn't a meteor. It's just a system shutdown.
Which brings us to the final sci-fi question. If we can see the code, can we hack the game?
Some physicists have suggested that what we're doing with something like the Large Hadron Collider could be a way to test the system's limits. The stack overflow theory.
Meaning, we ask the computer to process too much information in one tiny point in space-time.
And maybe we cause a system crash, a stack overflow error.
Risk is obvious. The simulation could just freeze. Or the creators notice us.
They notice their little science experiment is getting too smart and decide to shut it down.
But the reward?
The reward is sending a message, a glitch in the physics that says, we know.
And just before we go, let's hit the final mind bender, the recursive simulation.
We are already building our own simulations, virtual realities, the metaverse.
It seems inevitable that our simulated characters will eventually build their own simulations.
Creating a stack, an endless tower of realities, one inside the other. We could be on level 50.
And the implication is, if we turn off our computer, do we kill an entire universe below us?
And if the reality above us powers down, we all just vanish.
So we've covered the statistical probability, the clues in the physics, the glitches in our minds. The evidence is, well, it's compelling, even if you can't prove it. So what does this mean for you, listening right now? If life is a game, what's the objective?
If you look at the best open-world games, the goal is never just to survive or get rich. The goal is always experience and exploration.
Exactly. So the mission for you, the player, is actually simple. And it's liberating. Explore the map, travel, level up your character, learn new skills.
Complete the side quests, build relationships, help people, try to find an Easter egg or two.
And this connects back to the whole suffering problem. If conflict is just necessary data for the creators, then surviving it and learning from it, that's the whole point.
The takeaway really is that if this reality is being generated for you, the player, the only way to lose the game is to be boring.
To take it all too seriously. Stop worrying so much about what all the potential NPCs around you think.
Take some smart risks. Challenge your own assumptions. Explore the full potential of this existence.
It's the ultimate freedom, right? Knowing the rules are probably just code.
That's all the time we have for this deep dive into the simulation.
Until next time, we hope your reality remains wonderfully, chaotically stable.